All right, so we can begin today's class. Let me say a few words, introduce myself. I'm Dr. Xiaodan Gu. I'm happy to teach you guys for this semester's Polymer Physics. This is going to be very different with other two courses you guys are learning, mostly focusing on polymer chemistry, right? I'm excited to see a big class. We have been doing a lot of virtual teachings last year, and it's great to be back in the classroom. I hope everybody is excited as well. So let me begin, comment a few words about this class and what's the goal and what we are trying to do for this polymer physics class. So I want to ask a little bit sort of background question. So how many of you are coming from a background in chemistry? If you can raise your hand. So we got about, I'm a little bit slow, so 8. Great. How many of you are coming from an engineering background? Okay, good. You can of course have both. 1, 2, 3, 4. Maybe that was 8. Now we have about 6. And how many of you come with a background more in the physics or other? Okay, not many, right? So this is giving me great opportunity to teach you guys about polymer physics. I'm excited for it. Absolutely. So when I speak about polymer physics, I want what everybody think about it. When I speak about polymer physics, what's your first impression?
A lot of math.
That's true. That's true. There will be some math involved, but I think that for the couple years back when I was teaching, I'm pretty sure I want to give some general backgrounds about those math concepts. Make sure everybody is on the same page, because some of you are coming from chemistry background, right? So that will be done. I'll make sure math is not a challenge, and I'll sure everybody can get up to the speed. Okay. Any other thoughts, feelings when you guys first heard about polymer physics? All right. Let me give you kind of my thinks about where the polymer physics comes into play. Now imagine you guys did a fantastic job in your graduate school. You finished your PhD within 4 years. You landed on a dream job somewhere near Atlanta, let's say. You got paid $150K a year. You now is in charge of developing a new polymer that's going to replace this iPad's metal back case. So what's your job will look like? You're going to be managing a bunch of technicians, research scientists. You need to have a knowledge going from chemistry, physics, and engineering to design a new product. Okay? Chemistry specific means when we design a new material, we need to think about what's something new material we can put in, right? New chemistry to build a more softer, more rigid, more UV resistance, more impact resistance, right? Many factors you need to consider. So chemistry only gives you a molecular, right? You draw the structure. You're gonna get the best education here as well from the other two mentors, from Dr. Adole and Dr. Patton. You guys already probably had a class yesterday, so you're gonna learn all about these. Now, when I think about that, I usually think about, okay, I can think about envision yourself in a Michelin restaurant. Now this time is in New York City. Different setting. What's the difference between Michelin restaurant with a cane raiding the chicken outside our campus? That's another popular restaurant. They're not much difference, right? They both start with certain material, but how people cook them, present them, is different, and serve them, right? So I want to give the analogy to our course. There's no difference between a top chemical company with a mediocre chemical company. They both start with the same material. They almost buy from the same vendor. But what the differentiates then is the knowledge how to process to reach the property they want. Here, chemistry provides all the same ingredients. So think about a restaurant, a chef, you get all the similar ingredients. I would like to call it chemistry part of your course. You go to the field, you grow the best vegetables. That's what the chemists do, is to prepare the best material available to you so that you can engineer to the later parts. So where's my role comes into play? Physics and engineering are sort of entangled together because we don't teach, in your graduate school, you don't see a polymer engineering class, right? It's pretty much kind of rolled into the polymer lab, calculation lab. You guys will learn. I don't think it's started yet, but you guys will learn. And there's also a portion related to polymer physics, which is what I'm going to teach. So my role is to help you guys to understand at what temperature you need to cook your vegetable and chicken to make them tender, not overcooked. I'm going to teach you guys how to make the best grill for your steaks, so you can control it's well done or medium rare, or some people want totally rare. That's fine, but you need to learn the knowledge how to make them. That's the point of this class, is to help you guys to understand what's the fundamental behind it. All right? So at what condition your polymers will start to flow, and what are the other characteristics we need to understand. So it's a little bit basic, but I'll try to teach it such that it will be simple to understand and it will connect to as much live example as you can associate to. Okay? So that's the background of this class. And I will teach everything based on the Canvas. Have everybody had a chance to look into the software of the Canvas, be familiar with it? Okay, if you have already done it, great. Because I'm very slow learning new technique. It took me quite some time. But now this is like the third year I'm teaching using the Canvas shell. I already published all the course material there. You feel welcome to go there and look at all these lecture notes. I will give a brief overview of what we're going to do in this semester right now, because it's important to give you guys some understanding of the syllabus, right? What's the syllabus? So we're going to do 3 things in this semester. So polymer physics is very big. And in one semester time, I cannot cover everything. So we're going to divide by 3 great professors to teach you guys about this. I'm the first one. I'm going to help you guys to understand 1/3 of it. Then in the next semester, you guys have a little bit more advanced polymer physics 2 and 3. 2 going to be taught by Professor Young Simon, and 3 going to be by Professor Dr. Sergei Nazarenko. Okay? So there's 3 parts. And the textbook we're going to use is a polymer chemistry textbook. I think if you have not got one, go ahead and order one. This is a very excellent textbook written by Hearns and Ting Lodge. It's very good. It is written in a very simple to understand language. So if you go through my syllabus, this is a recommended textbook. We're going to do our teaching almost exclusively based on this textbook. And we're going to teach everybody 3 important topics to start with. So those are going to be very simple, basic parts of polymer physics. So what are these? So I want to ask you guys, what is the most simplest polymer physics you can think about?
Melting.
Melting, oh good. Good guess. What else? Other than melting. Glass transition, good. That's another good one. Unfortunately, I don't teach both of these. These are going to belong to Dr. Nazarenko. Okay, anything else? Chain movements, great. That's close to what I'm going to teach. So any more feedback? I saw someone raise their hand. Say that again? Viscosity, yeah. That's all very relevant to what I'm going to teach. So I'm going to teach actually most of the fundamental parts. I'm going to teach how the polymer chain looks like at nanoscale. Okay, so So fundamentally, if you think about polymer with respect to other material, it's very interesting historical discovery for polymer. It's probably not too much interesting to talk nowadays, but back 100 years, so 2020 was the year of 100-year anniversary for polymer science. And when generally people think about polymer science, it's the onset point of a famous professor called Stordinger proposed the idea there is a polymer because in 1920, nobody believes there's a polymer. If you talk about polymer in a conference, people think you're crazy. You got something wrong with your head, or if you had too much drinks, you're high or something. Because everything is centered on small molecular. So individual polymer, individual moleculars, a lot of phenomenon people see sound like something error with the instrument. For example, viscosity, dependence on molecular weight was very fundamental, but nobody believed it back then. So back that time, the number one thing people need to convince others is their existing of polymer. So in the first part of the lecture, we're going to actually revisit some of the early days development about polymers, why there is polymer chain, and how polymer chain behave differently with small molecule. It's very different. I remember we did an outreach event to a local elementary school. I'm probably going to repeat that experiment to show what I mean by polymers is very different with small molecular. We're going to do some interaction later on in the future class. So the first part, we're going to teach everybody about what is polymer, fundamentally. What are they different with small molecular, etc. So if you go to that book, it's going to be chapter 6 about polymer conformations. Everything relevant to how does the polymer chain looks like will be taught in about 1 month's time frame. So from now to late September, we're going to cover every single model people discovered about polymer and understand what is polymer chain look like at nanoscale. How do they look like and how do they compare it with other material. Okay, so this is the first portion of the class. Understand what's a polymer and what is the difference between the polymer. We can actually do a lot of things with those basic understanding to predict, for example, their viscosity, to predict their rigidity, and predict their mechanical property to some degree, okay? So that's the first part. Then, in the second month of this lecture, sometime in October, we're now going to go into something different because the first part is introduction and very abstract. The second part will be more relevant. Specifically, I mean relevant is those are something you're going to use possibly down the road. And those are polymer in solution. So think about there's 2 ways you can process the polymer. Either you're going to melt them, do melt extrusion, do melt processing, or you're going to solution process them, dissolve them in a solvent so you can cast them or do something with the polymer, right? If you want to make them into useful form, it has to go through one of those 2 processes. So that's where we're going to talk about. How do you choose a good solvent? What is polymer and solvent interactions? And there is a very famous professors in this area is called Paul Flory, and he's like godfather for the polymer physics field, because he is the one like even in the early 50s, 60s, using just a pen and paper predicted many properties people 20, 30 years later on found that's true, such as polymer melts, polymer in good solution, bad solution. Those are all being predicted back then. So we're going to cover all the details about how the polymer is behaving in solvents. Okay? So very fundamental as well. Then the last part is I call it a little bit in the specialized area. We're going to cover chapter 10, The other part is chapter 6 and 7 in the book. Chapter 7 is all about polymer solution. I think if I'm not mistaken, chapter 10 is about rubber elasticity. So we're going to talk everything about how rubber materials are being used and being understood as a useful material, and why rubber possesses some of the unique properties compared to other polymers. Okay? So that's kind of an overview of the class. So by the end of the lecture, you should expect to learn all those fundamental concepts about polymer physics. So when you cook your next steak, you should have some idea what fire you need, how high the temperature you need to turn it on, and what sauces you're going to add on to make it really good. So the class will include mostly lectures like this. So I'm going to lecture you guys about all the courses. So we're going to put on PowerPoints later on when we have the real lecture. And all the lecture PowerPoint notes are already posted in the Canvas. If you go there, you should be able to find it. If you cannot access it, just send me a message. Additionally, what I also like to do is some of the lectures can be a bit long, and I was a student before. I can focus maybe 10-15 minutes, and I would be drifted away for 5 minutes and come back again. It's just my real personal experience. So I'm going to record the class, and I'll post it there. So if you missed a point or two in the lecture, you feel free to welcome to go back and rewatch that specific portion whenever you like. And if you have some personal travels, you cannot make it into the class, you can also use that as an opportunity to revisit some of the courses, but don't overuse it, right? Don't abuse it. So if you have to travel, let me know in advance. Or if you are somehow had a COVID or not feel comfortable, you have to isolate from home, you can also use that. That's where I set up the camera. I'm going to do something they call live broadcast. So you will be able to watch it asynchronously anywhere in the world if you have a good internet. Okay? There's how we grade the course is another important question I think everybody cares about. So there's homework. And my philosophy is homework can be tough. And I probably will assign the most difficult homeworks among all the professors here. But my test will be average. So if you can do all the homework, the average difficulty for the final test will be a breeze for you. Okay? So expect to work a little bit harder during the semester in the homework, but you will be rewarded at the final test. So there's homework, maybe occupy, I don't remember exact fraction in the syllabus, but something like 20-30% for the homework. Then there's some occasional quizzes in the class. The quizzes is more for me to understand how everybody understands. So this is maybe 10-20% of the final grade. So what we're going to do is not numerical question. Typically, it's just to ask a few concepts, see if you followed in the past few lectures. Okay? And there's a midterm exam, then there's a final exam. Okay? So midterm exam is going to happen somewhere mid-October, and that will cover mostly in the first chapter 6. So far, any question for me regarding the overview of the class, and what are we going to do with the class, what kind of homework will look like? All right, I love question, please.
So you mentioned the midterm covers chapter 6, so I guess the final exam, is that comprehensive, or is that going to cover chapter 7 and 10?
Yeah, it will be comprehensive, but more focused on the later part, only touch a few points on the chapter 6, okay? So, and I think this school year, everything is going to be finished right about early December. So we will follow the schedule. I'll make sure I'll assign some of the classes near the end to give an overview of the courses, get everybody ready for the final. Any other question related to the course material, the textbook, and the format of delivery? Anything else? What other point I want to make? Okay. I think that's pretty much from me. What I want to know about what I want to say about the class. Now I want to use the next 10, 15 minutes to get to know a little bit more about you, what your backgrounds are, and your name, where your backgrounds are, and what something like that. Maybe introduce yourself to me. Can we do from here, then go back and forth? Would that work? Yeah.
Hey, Dr. Chang, I'm coming back. I graduated here, USM, just last year, and
Okay.
had your class. And I'm coming back for a PhD because it opened up my job opportunities, and particularly, I think I want to be a teacher, professor one day.
Okay. And your training background is more on the engineering side?
Engineering, yes, sir.
Okay, nice meeting.
So I'm Anthony. I'm from Los Angeles, California.
Okay.
I went to Cal Poly to do my bachelor's in biochemistry and then a master's in polymers and coating science.
Okay.
So I finished that up. I worked at an architectural coatings company. Then I did R&D for aerospace coatings. And then right after that, I came here to start a PhD program.
You know, we have very strong coding program here. We have Professor James Rollins works on coding for quite a long time, for mostly in anti-corrosion area. Welcome, yeah. So your background is mostly chemistry.
Yeah.
Nice meeting.
Nice to meet you.
I'm Penelope. I'm from Louisville, Kentucky, but I graduated from the Polymer Science and Engineering program at Case Western in the spring.
Yeah. That's another great polymer program.
Yeah.
And your background is mostly in chemistry or engineering? And okay, good. Nice meeting you.
Hi, I'm Janicia Shorter. I'm originally from Pembroke, Arkansas. I recently graduated with a bachelor in chemistry from Jackson State University.
Welcome.
I have a biology minor, so that's my background. The reason I wanted to come to grad school, in this one particular, is I did the RAU program in 2019.
Yeah.
And I really love the experience. It kind of positioned me more particularly for polymers.
Yeah.
I always knew I wanted to go back to do engineering for graduate.
Yeah, welcome back. Yeah, we should have more Jackson State students. We were hoping to recruit more, but hopefully you can help us down the road.
People that graduated, especially from the chem department, they went to pharmacy school.
Oh yeah, the dark money, they lure them away.
Yeah.
Anyway, nice meeting.
Howdy, I'm Jackie. I went to LSU for undergrad, got a degree in chemistry. Spent a year and a half at the University of Massachusetts Amherst in their chemistry PhD school before transferring here.
I see. I think you're one of the mid-year student, right?
Yes.
Great.
I came in January.
Yeah, nice meeting you.
Hi, I'm Ethan Rose. I'm from Evansville, Indiana. I graduated from the University of Southern Indiana in biochemistry. And I like to play sports. I want to take up tennis and play tennis more here.
Nice. Welcome aboard. Yeah.
I'm Evan Stacy. I'm from Louisville, Kentucky, and I did my degree in chemistry at Hanover College, and that's in Southern Indiana.
Yeah. So you guys are physically could be close. How far is it like?
Yeah, well, I came from Southwest Indiana. He came from Southeast Indiana.
Okay. Still a little bit away, but welcome both.
Hello, my name's Trey from Pennsylvania. My background is more plastics engineering.
I remember we have recruited 2 Penn State area students. That's a great achievement. We have had a great pleasure to have Allison graduate from here. She is a superstar here back in Penn State area. She does. I met her a couple months back. There was a Flash DSC conference virtually online. I met her and I saw, nice. We have a Southern Miss alumni there in the speaker lineup. It was a great pleasure to chat up with her. Okay, so you were one of them, and tell me a little bit more about yourself.
I don't really know. I guess I came to the PhD program because I wanted to get into teaching someday. I wanted to get into industry, more research and development side rather than like a processing or design side of things.
Sure. Nice meeting you.
My name's Nick. I'm from Pittsburgh, Pennsylvania, and I'm the other Penn State area graduate. I really like the research I was doing there, so
Sure.
I decided to come get a PhD. I'm really interested. I like playing soccer. I also am a huge hockey fan, so I watch the Pittsburgh Penguins all the time.
Okay, nice meeting you. Yeah.
I'm Jeff, and I got a BS in chemistry in 2010, and then I went to work for a polymer manufacturer in northern Massachusetts. Went there for roughly 6 years. I was in a lab environment running generally 1 gallon emulsion polymerizations, and then after that I moved into I went to a company that made paper additives. So still using polymers, but on the applications end.
Yeah.
Of it.
So you got a very strong industrial work experience background.
It's also been a while since I've been in school. It's been
Welcome back.
11 years.
Yeah.
Thank you for this.
Yeah, welcome back. So, David.
David Walker, remember me from last semester.
Yeah.
Graduated in the spring, polymer science engineer.
Yeah.
And my interests lie mostly in the aerospace composite area. So I came back to pretty much advance my expertise overall and then focus more there.
Okay. Good to see you again, David. Yeah.
My name is Andrew Holcraft. My background is chemistry, plastics engineering from Western Washington University. So about as far away from home as I can go.
Yeah. How many West Washington we recruited this year? Only you, or we got a?
Me this year, which is kind of surprising.
Yeah, it is surprising. We usually have 2 or 3.
Yeah.
Some of you, but welcome.
I've been in industry for about 7 years in R&D the whole time.
Okay.
I've been going to grad school in chemical engineering for the past 1.5 years or so.
Okay.
I made the switch because I've been promoted to a point where I can no longer be promoted. So this is the next step. Once I'm done here, I'm going right back. I love my job. I got a job waiting for me, ready to go.
Good. Sounds like a very clear path. You will be highly motivated to go straight to graduation, huh?
And if anyone's interested in aerospace composites and industries, you want some reference, let me know. Got 7 years of learning a lot of people in the trade, so let me know.
All right, great.
Hi, I'm Chantal Frexmeyer. I graduated from Virginia Tech in 2018 with a degree in biomedical sciences. I worked in industry for about 1.5 years at a polymer verification lab running GPC primarily. The reason why I want to go to grad school though is because I have a passion for cosmetic chemistry and want to eventually start my own business with that.
Wow, that's exciting. I haven't heard a lot from students saying they want to start entrepreneurship. I think that's what the state of Mississippi is urgently need. So many other places, of course. Welcome aboard.
Hi, I'm Krita. I'm a MBA student. I joined last spring semester and completed my graduation from the University of Calcutta in India. So I have a 2 bachelor's degree, one in chemistry, and then I done the second one in polymer science and engineering. That's pretty much about my background.
Okay, welcome. Yeah.
Hey, Dr. Yu. I'm Chandler. I graduated from this department 2 years ago, and I've been working for Dr. Azoulay since. But I just came back to grad school because I wanted to challenge myself, and I find that I get bored when I'm not pushing myself academically. So.
Okay, good. Welcome back. I know you got a lot of challenges. Dr. Azoulay raised a very high bar for all the students. I'm sure you got a lot of good opportunity to try those. Are you more on the chemistry side in the lab or in the device characterization?
I did the synthesis side.
Cool. Last but not least.
I'm Andrew Bates. I completed my undergraduate here. I wanted to do more lab work, and I really liked it here, so I'm back.
Okay, welcome. And you worked with Dr. Wiggins before you in the undergraduate. Okay, good. Well, I think we got a good balance of all kind of background, and I'm very happy to see we have more students has industrial background. A lot of time it's kind of harder for me to think when you need to make this switch, because you're making a lot of money already in the industry. But I really appreciate you coming back to graduate school to further your degree of education. I saw several of you have this kind of pathway. We also have a lot of good transfer student and a lot of regional students from Jackson State. I'm very happy to see it. So welcome on board, everybody. I'm beyond thrilled to teach everybody the coming semester about polymer physics. So I hope by the end of semester, you guys have a little bit better understanding what the polymer physics are. Okay? So that's going to be wrapping up the first lecture. So beginning the next lecture, we're going to start to talk about fundamental concepts. So I usually suggest students do a little bit reading before the class. That will help you better understand it. We have two ways to accomplish it. Either you want to go through the textbook, that's fine. There's 6.1 and 6.2 is a great introduction for the next lecture. So feel free to get started on that. Or we have the option 2 is we fortunately have recorded the last year's lecture for lecture 1. It's not going to be too long. If you want to directly jump into what we talked about last year, you can also do that either way. Okay, then otherwise I'll see everybody at this Thursday. Sounds good?
Thank you. Is 6.1 and 6.2 alignment is a lot?
Yes.
All right.
Right.
Do you mind if I talk to you for a second after?
Sure.